Hello everyone. Today we're talking about distance on a number line. And we're going to use some topics that you already know how to use. Addition, as well as fundamental algebra and problem solving. The idea with distance on a number line deals with the concept of betweenness of points, illustrated here, such that point M is between points P and Q if and only if P, Q, and M are collinear. There's that key word again, folks, collinear. And PM plus MQ is equal to PQ, such that if PQ is the total distance, M is between the two, if we can take the distance between PM and the distance between MQ, add them up, and get the full distance from P to Q. And folks, I know some of you are thinking, this is addition. You've been doing this since elementary school. Good news, you're right. So, how you might see it in problem form. Give an example 1. Find each measure. Assume the figures are not drawn to scale. Okay. It wants us to find EG, and we have here E and G. We don't yet know the full distance from E to G, but we know that from E to F, we have 2 3/4 inches. And then from F to G, we have 2 3/4 inches. So the idea here is that we set up our equation, as they did here, with betweenness of points. That point F is located between points E and G. We're then going to substitute what we know. We know that the distance between E and F is 2 3/4 inches. So we're going to put that here. Get that arrow going. We also know that the distance between E and G is 2 3/4 inches. So we're going to put that there. Well, now we have two numbers equals an unknown quantity. We combine our like terms. 2 3/4 plus 2 3/4 gives us 5.5 inches, indicating that the full distance here between E and G is equal to 5.5 inches, or if you want, 5.5 inches. Now folks, those are the basics. It's unlikely you're going to see something like this on a quiz or a test. You're probably going to see it though with variables. So let's take a look at example 2. We want to write and solve equations to find measurements. And folks, just like it says here, algebra, we're going to use algebra concepts to work out this problem. We want to find the value of a and xy if y is between x and z, and xy is equal to 3a, xz is equal to 5a minus 4, and yz is equal to 14. Now folks, in these sorts of problems, it's usually a good idea to draw a picture, and they've already gone ahead and drawn the picture for us, such that the distance between x and z is indicated by 5a minus 4. The distance between x and y is indicated by 3a, and the distance between y and z is indicated by the value of 14. So, first step, write out our fundamental equation, as they did here, that the full distance, xz, is equal to xy plus yz. The full distance is equal to this part plus that part. Then they substitute what they know. The full distance is 5a minus 4, whereas the partial distances are 3a and 14. Well, now we have our setup of 5a minus 4 is equal to 3a plus 14. At this point, folks, you should know to combine like terms and simplify down to the variable on one side and some number on the other. Now, working through the example, they then subtracted 3a from both sides, simplified that to give 2a minus 4 equals 14. To get rid of that minus 4, they added 4 to both sides, gave them 2a is equal to 18, divide each side by 2, a equals 9. Fully worked out problem. Now folks, I'm going to pause the video. I'm going to draw a problem of my own, and we're going to work it through in the same capacity. And we're back, folks. So, we have the problem of we have to find 23x minus 15, and all we have to work with is a 20 and a 16x. So we're going to need to solve for x and then verify our answer. So, we know the full distance here is 23x minus 15. We know that has to be equal because of our betweenness of points, has to be equal to the component parts of 16x plus 20. Now, we should simplify, combine like terms. First things first, I'm going to move that 15 over by adding 15 to both sides. That will give me 23x is equal to 16x plus 35. Now I want to take that, now I want to combine my x's. 23x versus 16x, it's going to be easier to subtract 16x from both sides. Subtract 16x from both sides, and we should get 7x is equal to 35. All right, now we need to isolate that x value, divide both sides by 7. Those cancel out, and that should give us x is equal to 5. We could go back if we wanted to, plug in our values to make sure, and if we did, we took this x equals 5 and plugged it back there, we should see that 100 is equal to 20 plus 80. All right. Folks, if you have questions, please feel free to email me, ask, so on and so forth. So, key terms, congruent. If two things are congruent, they're going to share the same shape and size. So when we start talking about shapes like circles, triangles, squares, rectangles, you might hear me talk about congruent triangles, congruent squares. But for now, congruent just means the same shape and size, and we can apply it to line segments to give us the key concept of congruent segments. Congruent segments have the same measure. We use this little squiggly key thingy over the equal sign to indicate congruent. Also, if you see red slashes, that usually indicates congruency. One red slash is congruent to the other red slash. Two red slashes is congruent to the other thing that has two red slashes, and so on and so forth. The more things are congruent, the more potential red slashes you might see. An example of how this looks written out, segment AB is congruent to segment CD. And written out here for us. Now this is going to become important for a few other things we're going to do. Because now we're going to go into the distance formula on a number line. And folks, the distance formula uses absolute values. It uses absolute values because an absolute value will never give you a negative answer. And this is important because distances can never be negative. But the idea being, if there are 2 points on a number line, then we can find the distance between them by basically subtracting one value from the other. Segment PQ is interchangeable, is congruent between QP. So no matter which way we write this, it should be fine. But that's also why we have the absolute values. That way, we avoid getting any negative values. How might we apply this? Well, take a look here at example 3. Find the distance on a number line. Use the number line provided here. We want to find BE. We want to find the distance between B here and E over there. Well, first things first, we have our distance formula of our x2 minus x1. Well, the x2 in this case refers to the first value, second value. X1 refers to the other value. With how the writer set this up, x2 is equal to 2, x1 is equal to -6, because we're going from B, which is -6, to E, which is at 2. So the second term minus the first term, absolute value of that. 2 minus -6. Folks, as you may recall, negative and a negative make a positive. So we have the absolute value of 8, or simply 8, once we simplify, indicating that the distance between -6 and +2 is 8. And I know, folks, some of you might be thinking, oh, that's easy. Why couldn't I just take -6 and add 8 to it and say, hey, there we are? You're actually right. For now, that is really all we're doing. But tomorrow, we're going to start applying this to a coordinate system. And that's where we're going to have to keep our values consistent. But let's move on with our practices. We want to determine whether CA and ED are congruent. That is to say, we want to see if CA has the same measurement, the same length as ED. Well, CA, our C value is -4, our A value is -7, so we're looking at the segment here. Well, that's going to give us -7 minus -4, absolute value of -3, or 3. So if CA and ED are congruent, they'll both equal 3. Well, we check ED. ED runs from 2 to -2. So we have -2 minus 2, which is the absolute value of -4, which is 4. Because 3 is not the same as 4, the segments are not congruent. All right, let's take a look at practice of our own. We want to find the distance between A and D. Well, A looks like it's at -7. D looks like we're at -2. Distance formula, absolute value of x2 minus x1, absolute value. Plug in our values. We have a -2, absolute value of that, -2 minus a -7, absolute value of that. Well, -2 minus -7, that's the same as -2 plus 7. Gives us the absolute value of 5. Absolute value of 5 equals 5. There are 5 points. There's a distance of 5. existing between A and D. And again, folks, I know some of you are looking at the number line. Well, -7, -2, there are 5 points between them. I get it. We're just showing it out algebraically. All right, last practice. Determine whether CF and AE are congruent. So CF, our C value is -4. Our F value is 5. Our A value is -7. And our E value is 2. All right, so we're going to do our split here. And if they're congruent, both sides should be equal to each other. So, set things up. The absolute value of 5 minus a -4, close the absolute value. That gives us the absolute value of 9, which gives us 9. On the other side, absolute value of 2 minus -7, close absolute value. Absolute value of 2 plus 7, absolute value of 9, 9. 9 is equal to 9, so CF and AE are both congruent.